we have tools in research, tools in diagnostics, tools in therapeutics that we have never had before, which are truly amazing. And I think that we're seeing the fruits of that in longer survivals, earlier detections, better surgical techniques. But we're also fighting the smartest enemy that we can fight.
This is a tumor. This is all cancer, and it's ruptured, and all of this is inflammation.
The same cancers that affect people oftentimes affect dogs and cats. And I think what researchers are starting to recognize is that the best predictor of a successful drug on the human side is how well those drugs perform in a naturally occurring cancer model.
Comparative oncology is the scientific study of how cancers that develop naturally in dogs and cats and other companion species share genomic, biologic features with human cancers that also develop spontaneously.
What we have learned over the last 50 years is that cancer is a syndrome that occurs as a result of abnormal cell growth.
Malignant cancers are usually doing that. They're spreading out like little fingers everywhere.
What we still need is larger clinical trials, more information about how we take that information and turn that to the benefit of the patient in as many cases as possible.
The most important thing to know about comparative oncology is that dogs with cancer are patients, part of a living human family, and the study of them is a huge privilege and opportunity and a really exciting moment for veterinarians around the world.
It benefits both ends of the leash.
The first real organized descriptions of tumors in domestic animals happened in the 17 and 1800s. So the individuals who were interested in treating companion animals for cancer were also very deeply steeped in the research of human cancers at the time, looking at doing clinical studies that had potential translational capability.
We are here today for the purpose of signing the Cancer Act of 1971. The Congress is totally committed to provide the funds that are necessary, whatever is necessary, for the conquest of cancer.
Back in the 70s, when the war on cancer was sort of declared, people got the wrong impression. They thought all cancers behaved the same and we really just needed to find a drug to treat cancer.
Cancer is like a puzzle. And if you think about a puzzle that has no color on it, it's just the cardboard pieces. It's very hard to fit those together in a way that makes sense. And so researchers, scientists, and doctors all over the world are trying to fit those puzzle pieces together in an effort to treat cancer.
In 2003, the Human Genome Project successfully sequenced the majority of the human genome. This discovery and the technology that followed helped to open a floodgate of information.
Our genome is our instruction manual. Every cell in our body contains the same copy of our genome of that instruction manual. That instruction manual is made up of a 4-letter alphabet, A, T, G, and C. Those A's, T's, G's, and C's are strung together to form words. Those are genes. Those genes are strung together into pathways. Those form sentences and paragraphs. Those control everything that our cells do.
There are certain genes in our body that control the rate of cell growth. These genes help a cell grow, it helps a cell divide. And a mutation can happen in one of these genes that it's like pushing a gas pedal down, and it makes the cell go out of control and it proliferates like crazy. Other genes stop a cell from growing. If you mutate one of these protective genes, called tumor suppressors, then you end up getting a cell that has no brakes. There are no checks in place.
For a normal cell, if you have DNA damage, there are safeguards that actually force that cell to stop dividing and actually tell that cell to commit suicide. That's called programmed cell death or apoptosis. Where we get into problems is that if we have cells that either are normal, that don't die, or if they're mutated, they don't die.
So cancer is as much a dysfunction of cell growth as it is a failure of the immune system to adequately respond and eradicate tumor cells.
Some of these tumors are so clever, they actually put molecules into the circulation that fool your immune system to thinking that it's okay, that this cell is actually normal, when in fact it's a cancer cell. So your immune system just ignores it and the cancer continues to grow.
And once that happens, the cancer itself bends the immune system to its own will and borrows the immune system components to protect it. It creates around itself really a zone of immunosuppression, a zone of protection, so that the immune system can't get in and eliminate the enemy.
This is a dog here who has an osteosarcoma within the humerus, so within the upper forearm. So you see another mass lesion here. This is the site of a local lymph node, which is the superficial cervical lymph node. So this is called metastasis. This is when the tumor itself spreads to the local lymph nodes or to the lung or other regions within the body.
Our ability to use genomic technology to look at the DNA alphabet, to look for any errors in that alphabet that we call mutations, that ability is critically important for helping us better understand what's going on with cancer.
Genomics has allowed us to paint a picture on those puzzle pieces. So now each individual puzzle piece is unique, and its picture is different than every other piece in that 1,000-piece puzzle.
The fact that we are now being able to find out all of the different mutations and what those mutations look like in cancers has given us a tremendous ability to not only understand how these cancers are arising, but also be able to compare between dogs and people.
In 2005, the genome of a purebred boxer was sequenced, and investigators discovered that dogs are a very close genetic match to humans.
The genomes are remarkably similar in terms of gene structure, composition, and function. The human genome is slightly larger than the canine genome. The canine genome has more chromosomes than the human genome, but the actual number of genes, what those genes do, how those genes work together in pathways, how they form the sentences and paragraphs that get work done in our cells, those have all surprised us, I think, in terms of how similar they are across the species, particularly when you think about how physically different we are and how physiologically different we are.
From its beginning, veterinary oncology has always looked to physician oncology. If your dog is sharing your dinner and maybe sleeping in your bed at night and going on walks with you, they have the same environmental exposures you have. So in turn, their immune systems are similarly educated.
They make a good model. Now, I want to be careful when we use the word model because that's almost making us think that we're treating them like a lab animal. They're not, they're a pet. They're part of a family. They have a shorter lifespan than us though, which is sad, but allows us to see the progression of disease quicker.
So if we can understand their diseases, we're not just helping them, but they're helping us as well.
There's been several areas in oncology, let's say bone marrow transplants were figured out in dogs before they went on to be a human therapy. Limb-sparing surgeries were figured out in dogs so they could save kids' legs if they developed a bone tumor.
A lot of folks really had no idea that dogs were getting cancer naturally throughout their lifespans at that time. And so it has really become, I think, an important outlet for advocacy and awareness.
So the National Cancer Institute had the wisdom to put this group together of veterinary oncologists in academic and private practice settings to set up really collaborative trials.
The comparative oncology program was founded by Dr. Chan Khanna at the National Institutes of Health within the pediatric oncology branch in 2003. And it was created because Chand and others within the pediatric oncology community were very focused on that comparative biology of osteosarcoma, which is a rare and devastating bone cancer of children, adolescents, and young adults, but also a major medical problem for the veterinary medical community. The Comparative Oncology Trials Consortium is a group of veterinary academic centers, so veterinary schools throughout the US and Canada, that have agreed to bind together and work with the National Cancer Institute's comparative oncology program to execute multi-site clinical trials.
The goals of those trials is to generate rapidly high-value biologic data that will be informative in guiding parallel studies for people.
It takes into account their natural immune system, how it's fighting or preventing this cancer from developing, and the genetic underpinnings in that particular cancer patient.
Those trials are designed to assess the efficacy of drugs in the treatment of cancer, agnostic of who has the cancer, whether it's a pet or whether it's a person.
The program was created to address those sort of gaps in our knowledge and to really have a focused effort to bring comparative oncology to the forefront of cancer research.
The cancers that we study are, I say spontaneous, are naturally occurring. We're not inducing any cancers. We're not giving any cancers in order to be able to test this in dogs. These are naturally arising for whatever reason, whether that's environmental exposure, genetics, or random chance, or a combination of all of the above.
A clinical trial is a way to try a new therapy. We do it in patients where we don't have a standard therapy or where they failed the standard therapy already. So we know they are not lab rats, they're family. We honor that bond. Clinical trials are really key to advancing science, but I think they can bring hope and helps that individual patient.
Brianna adopted Tyson from a local rescue when she was in college. He was her constant companion through good times and bad. When little Sophia was born, the three became a tightly knit family.
Almost 2 years ago, Tyson started limping really badly. We knew at a young age he had pretty bad arthritis. Initially, we just assumed that it was just the arthritis getting worse. I took him to multiple doctors and they told me that, hey, we found something on his leg. We aren't sure what it is, but it needs further evaluation. So we came in and they ended up telling me that it was the osteosarcoma, bone cancer. We were just like heartbroken because we knew that it wasn't good.
Osteosarcoma has a high rate of metastasis or spread, usually to the lung. We need to use chemotherapy afterwards to try and slow down that progression. And the dog, chemotherapy just isn't able to do that. It's able to slow things down, but it isn't able to clear all of the tumor cells from the body.
On the beginning, one of the doctors did let me know that they currently had a clinical trial going on for the osteosarcoma, and they would be willing to cover all costs after the amputation. He has a best friend named Jackie, and she's been in charge of pretty much all his care since the amputation. And all I have to do is mention Jackie, and Tyson is at the front door. We're ready to roll to Davis.
Some of the benefits with the trials for the owners, maybe depending on the trial financial benefits, it may be a treatment that they otherwise couldn't afford. This is kind of new groundbreaking on the edge technology. So they may be one of the first that they would have the benefits of either improvement of the disease, best case scenario that the disease is cured. They may just have the feeling that they're helping when otherwise they feel really helpless.
One of the clinical trials being investigated at UC Davis that paired well for Tyson was COTC 030, using inhaled interleukin-15, also known as IL-15.
IL-15 is a cytokine or a protein that naturally occurs in the body, in the lungs, as part of the immune system. This IL-15, if we can enhance it and get it directly onto the tumors that are in the lungs, that we'll have a better chance of either stopping or slowing down spread.
Our approach to interleukin-15 is unique in that we gave it via a nebulizer inhaled directly to the lungs.
I didn't know if what I was doing was a selfish thing or whether it was really the right thing to do. I just knew I had to try to help him.
Our hope is that IL-15, when it's combined with standard of care, will stimulate the immune system to help clean up the remaining tumor cells that are there that aren't responding to chemotherapy. Tyson was one of the first patients that was enrolled in this trial. He's a pretty fun-loving guy, just has a good time when he's here, really excited to come in and see us. The idea is to give more of it at a site-specific, directed locally so we get higher concentrations within the lungs, lower concentrations systemically so that side effects are minimized.
The clinical trials for IL-15 have gone pretty well. We haven't, unfortunately, had them long enough to really get a good sense of data, but there have been some animals that have really exceeded the general median survival time. One of them is Tyson, who is out almost 2 years past surgery.
We still come in every 6 weeks for follow-up visits for chest x-rays. And I truly believe that without having him in this clinical trial, he might not be here still with us.
We celebrate with the owners just as much as they do. Because they, usually at that point, we've become pretty close with both the owner and the animal. We're happy to see them, they're happy to see us, and it's a victory all around.
It's making lemonade out of lemons, right? So it's sad that dogs and cats and lots of companion species develop cancer naturally just as a consequence of being alive. But we can take what we can learn about those cancers and benefit them, but also benefit the humans that share their lives.
I was able to give Tyson a fighting chance, and however we end up, whether it does end up coming back for Tyson, I know I did the right thing.
UC Davis is continuing to analyze the data produced by this study, thanks to the support of heroes like Tyson, Brianna, and Sophia.
Clinical trials are necessary to comparative oncology. We won't learn unless we take what we have learned in the lab and applied it to naturally occurring cancers. We're learning, and the treatments are progressing with leaps and bounds. It's coming. I just want people to know that there is hope there.
Neurology in the veterinary world is a combination of both medicine and surgery. And from the surgery point of view, when they become paralyzed, they come and see us. We do emergency surgery, and seeing a dog walk again and just seeing them get all proud when they're taking their first steps, I mean, it's just so rewarding. Ever since I was little, I knew I wanted to work with animals. I always took care of my family pets the most. Haven became part of our family. We adopted her when she was an itty-bitty puppy, and our street that we live on is Winter Haven, and it means Haven is like a safe place. She went on all our road trips with us. We love the water, we love boating. She would jump off the dock with us. She would go on the boat with us. She was truly just another family member.
Wait. Yeah?
I actually took her with me to vet school at University of Illinois, and she was my guinea pig in a lot of ways. I would learn something in class or in clinic, and then I'd go home and test it on her. She really was there for me as support in those hard years.
I think we can see the tumor really well. This is a dog we saw yesterday and actually had 2 brain tumors, which we were not.
I had the goal of just finishing the 4 years and becoming a general practitioner. And then in between my 2nd and 3rd year of vet school, she started having seizures. So did a neuro exam, and the first recommendation is you should probably have an MRI of her brain to see what's causing that seizure. The MRI is quite expensive, especially if you don't have pet insurance. And in vet school, don't have that kind of money, but I wanted to know, and so I started just asking my classmates, how can I do this? How can we figure it out? And one of my classmates had recommended chatting with Dr. Fan, who was an oncologist who was doing a lot of research at U of I. They knew that he was starting to do a clinical trial with dogs who had cancer, and specifically wanting to do one with dogs who had brain tumors.
When we first were evaluating brain cancer, we had several pet owners who were really excited about being part of this clinical trial. They wanted to find something that had promise in helping their pets, and at the same time, the results could be useful and valuable to actually guide and develop treatment options in people with the same type of tumor.
So I contacted him and we met, and I ended up enrolling Haven in his study.
There's often a financial incentive to owners to enroll on a clinical trial, so us helping them pay for treatment, rechecks, imaging of their dog, blood work of their dog, and we do get quite a few owners that aren't able to do a lot since most owners don't have insurance for their pets. It all comes out of the pocket.
Cancer cells use a variety of means to continue to propagate and to evade the immune system. As chemists, we can make things that have never been made before, so totally new molecules. And we discovered a compound called PAC1 that turns on cell death in cancer cells specifically. And we published a paper on that in 2006. And at that point, Professor Fan had seen that work and was interested in using those compounds and that same approach to help pets with cancer.
The evasion of programmed cell death is a hallmark of cancer. And Paul Hergenrother, being a brilliant scientist he had envisioned, if I have cancer cells that evade cell death through different defects, can I design a small molecule that can actually step around those obstacles and directly activate cell death? He identified it as PAC1, which stands for the first procaspase 3 activating compound 1.
There's certain features in cancer cells that enable them to continue to grow and divide and become a tumor. One of those is certain inhibitors of these proteins. So procaspase 3 has an endogenous inhibitor, zinc. PAC1 binds to that zinc and enables procaspase 3 to become activated and kill the cancer cell. Those proteins tend to be overexpressed in many different cancers, and so based on that overexpression, we can get selectivity for cancer cells over normal cells, which is the big challenge in anti-cancer research.
I just remember having a lot of relief that I had found something for Haven.
PAC1 was evaluated in dogs with 2 different types of brain cancers, one being gliomas, and the other being meningiomas.
Haven was diagnosed with a meningioma. A meningioma is a tumor that arises from the lining of the brain, which are called meninges. So they basically grow from the outside of the brain and they press in on normal brain because they can't grow out because there's a skull right there. And meningiomas are the most common type of brain tumor in dogs.
For a dog with a brain tumor that's never surgically removed, we're trying to shrink a tumor that's quite large in these pets and they're already symptomatic.
PAC1 does have the feature of being blood-brain barrier penetrant, meaning it can get into the brain. We've treated pets with brain tumors successfully, and so we think it has promise for human brain cancers as well.
We believe that PAC1 has some single-agent activity, but it's going to be best utilized when we combine it with radiation therapy, or when we combine it with chemotherapy, or when we combine it with small molecule therapy, or when we combine it with immunotherapy.
We started receiving 2 types of chemotherapy, which she got at home. We were given a very specific schedule to administer the chemo. She had to get her chemotherapy in a small meatball, which is a small, canned food. And so I think she would say she loved it because she got more treats during that time. About 2 months into it, we then did a repeat MRI. And that was one of the best days because the repeat MRI showed that her tumor had shrunk, I still remember, 47% in volume. And it was the biggest celebration. But she still had seizures, and if there's something abnormal in the brain, dogs will continue to have seizures. And so maybe a month after her MRI, which had shown the tumor shrinkage, she had another round or cluster of seizures. Whenever a dog has more than 3 in 24 hours, that's deemed an emergency. And so she would have to go to the emergency room, and it was a big bill every single time. And so we had kind of just sat down as a family and said the next time that she has a cluster, we're gonna have to bring it into the ER, and that will be time. We don't want to push it too far to where we regret waiting too long. So ultimately, when she had a cluster, we ultimately decided to let her go. Even though we didn't get the outcome that I would have hoped for, which is her living until she's 30 years old, I think enrolling her in that trial was absolutely worth it, because I'm now a neurologist because of everything she went through. And she truly laid the foundation for this clinical trial to just continue growing and taking off and getting to the point where it is now. She helped other dogs, and other families. So yeah, I think the benefits of her experience in that trial, I can't even name them all. Haven's dog tag is on my stethoscope, so she's with me every single day at work, every day.
In 2023, PAC-1 was evaluated in 3 human clinical trials. The human phase 1 trials have shown promise in treating pancreatic neuroendocrine tumors, glioblastoma multiforme, and uveal melanoma. University of Illinois is hopeful that PAC-1 will be further advanced for evaluating its activity against pancreatic neuroendocrine tumors in a future phase 2 study. After the passing of their first dog, Jean and Lawrence Jones weren't quite ready to add another to the family. But when Jean saw that a litter of golden doodle puppies was available, well, they couldn't help but take a look.
I wanted the boy dog, so they handed me Hunter. And when she asked, "Oh, are you gonna take the one dog?" Lawrence speaks up and goes, "No, we're taking 2. Haley and Hunter, they're litter mates. So that's how we got both of our dogs.
We don't have kids, so we attach to our dogs.
They're our babies. So Haley likes treats. She's not much into running around as much as Hunter. Hunter is very active.
He likes to run, jump, swim, anything outdoors, and that's the kind of person I am, so it matches my personality.
And then one Sunday morning, all of a sudden he's limping.
And I thought it was a strain because he was out playing with the ball, and I thought, oh, he probably just pulled something.
So I'm the type of person who immediately I want to bring him to the doctors. I don't care what it is. If there's a scratch, if they have like a little abrasion, I'm bringing the dogs to the doctors that day. I don't wait. So that's what we did.
Hunter's sudden limp began the Joneses' leap of faith into the world of clinical trials.
I was really concerned what was going to happen, but we caught it very early.
A clinical trial is usually something that is using a novel approach and requires that we have both clinician and owner consent to utilize something that may be at different levels of research.
A lot of the benefits from clinical trials that pet owners can realize have a lot to do with the type of care that they receive, and then access to resources and treatments and advances that may not be commonplace or accessible to modern veterinary practice. So dogs that enter clinical trials are cared for at the highest level.
It's critical that we do clinical trials to understand how a therapy works and if it works.
I think if you choose your clinical trials well, then recruitment is something that clients really appreciate, and it does feed the entire oncology community. ECI is a novel way of addressing cancer. What they're hoping to do is harness the immune system to develop an individualized approach.
In 2015, Elias began a collaboration with the University of Missouri to begin clinical trials in pet dogs with osteosarcoma throughout select veterinary hospitals in the United States.
This gives veterinarians a chemotherapy-free approach to treating cancer in dogs. So we know that the immune system, particularly the T lymphocytes, fights foreign invaders. That's its role. In our clinical trial, we start with a personalized vaccine that is made from the patient's own cancer cells.
Through vaccine alone, those lymphocytes are often not activated enough, so they harvest those lymphocytes using a process called apheresis, where blood is exchanged through an apheresis machine that simply allows the removal of those lymphocytes from the blood. And then in a laboratory, those lymphocytes are expanded into much larger numbers.
We expand them so we have about 50 billion activated effector T cells, which we then infuse an IV infusion back into the dog. They've been primed against the cancer, and now they're going throughout the entire bloodstream and into the tissues of the dog to find those cancer cells, hunt them down, and kill them.
I had huge reservations beginning this study, in part because this study was specifically designed to contain no chemotherapy. And the one thing that we know about dogs with osteosarcoma is if we want them to survive very long after amputation, they have to have chemotherapy. So we had long discussions with Elias about the stopping rules in this study. Elias was very ethical in their approach to this. They really wanted to make sure that first we did no harm, and that we made sure that it was safe for the dogs and their families.
We had never heard of osteosarcoma, and I was devastated when they told me the prognosis of osteosarcoma. They said that the lifespan is 2 months to about a year. And then being part of the clinical trial, we don't know what's really going to happen or how he's going to be, and we're making these decisions for him. We can't ask him if he wants to be a part of this, so we're doing it to him, kind of like. So that was kind of scary.
Hello, my friend. How are you, buddy?
In order to be considered for the Elias clinical trial, they had to have no evidence of disease spread. They had to have a surgery done with a surgeon trained in the ECI harvesting process. They had to be large enough to safely undergo procedures included in the ECI trial, and they had to be otherwise healthy.
If this was going to help him have a longer life, I was all in. That trial was giving me hope.
The Joneses were extremely committed and really looking for something that may exceed what standard of care offered. And that, combined with Hunter's good health, really made him an excellent trial candidate.
He was the 100th dog on a 100-dog trial.
So, yeah.
So it had to move pretty quickly if we were going to go down this road.
Hunter is the sweetest, bounciest floofy floof that you'll ever meet. He completed the 18-month clinical trial already with flying colors, so his visits are now quarterly exams and x-rays. X-rays is really the biggest thing. We're monitoring for visible cancer spread, because we anticipate at the time that he had his surgery, he had what's known as micrometastasis, meaning that there were cancer cells in the lungs that we couldn't see, and without therapy, they would grow.
Being part of a clinical trial is a series of ups and downs, not because of the trial itself, but just the vast emotions that one has, knowing that a member of their family is ill and you're going down uncharted roads.
I'm terrified each time, I have to admit it.
I have nothing but good news.
Oh,
good.
Thank God.
I know.
We
it's
always
on
hold our
pins and
breath.
needles, absolutely.
Right.
So I always want to lead with that. His x-rays still look beautiful.
Oh, wonderful.
Yes.
I was nervous. I don't know. He had
Oh,
lost a
no.
couple pounds. I was scared.
Anything that you've done differently at home?
He's been walking more, but we didn't know if that was it or something was going on.
Well, you work out more, you lose weight.
So the fact that Hunter recovered well, tolerated his treatments well, that's my expectation. And I love that they surprised their families who maybe aren't as optimistic going in.
So almost 2.5 years, and we look fantastic.
Terrific.
Yeah.
Good job, Hunter dog.
Every time I get good test results for him, that's really exciting because I hope that means that we're moving the needle forward.
The two best things on this whole trial and this whole procedure was the fact that we have a healthy dog, 2.5 years later, still clean, and we were able to make a most unfortunate situation benefit not only himself, but everyone else going forward.
Many of us have family members that we've lost to cancer, pets that we've lost to cancer, and it's hard to go through that battle. And knowing that one day it might be different, that is huge as well. So sometimes it's about this trial, and a lot of times it's about this trial in the bigger picture.
Thanks to the efforts of the participants of the ECI clinical trials, its human counterpart, TVI Brain 1, received Fast Track designation by the FDA and has begun clinical trials for glioblastoma in humans. In 2024, ECI became the first adoptive cell therapy in veterinary medicine to receive approval from federal regulators. Cancer won't be cured tomorrow, but consider how far we've come. It may take time, but we can win this fight, and with our best friend by our side, hope will never be lost.
Our goal is to end cancer, really. We want to end suffering. We want to make cancer a disease that's always treatable, and always treatable whether it's in a person, whether it's in a dog, a horse, a cat, a bird, you name the species. We want to beat cancer.
We know cancer like we do a well-documented criminal. We have its DNA, we understand its mechanisms, we understand a lot about how things function. And the challenge continues to be, how do we put together that massive quantity of information to benefit more patients and have better outcomes?
What cancer researchers and veterinary medicine is doing is so incredibly important. And for pet owners, for pet parents, for pet families, this is life-changing work.
It's critically important that we continue to focus on using genomic technology to characterize individual patients, individual patient disease, to help us tailor treatment to be more effective, to be more cost-effective. We're learning more every day. Groups like ours, groups like Dr. LeBlanc's, are continuing to do critical research to move that understanding forward.
There is always hope. I think that every day, every week, you see articles come out with a new drug or a new combination of drugs that's shown efficacy in a population of people that didn't have any other options before.
Clinical trials offer the pet owner an opportunity to explore a range of treatment options and be supported in that endeavor financially. A veterinarian gets to witness sort of the entire span of that relationship that a family or an individual has with a companion animal in their life. And being able to care for them in a clinical trial setting that is very similar to what a human patient would go through in terms of cancer care is a really exciting opportunity for veterinarians to make things better for the dogs and cats that they care for, but then also feel like they're making an advancement for human cancer care as well.
As of the completion of My Friend Radical Hope, both Tyson and Hunter remain cancer-free.
You need a hero, I got you. You need a friend, I got you. You best amigo, I got you. Until the end, I got you. I got you. I got you. I never judge, I got you. Always forgive you, I got you. Won't hold a grudge, I got you. Just wanna live with you, I got you. I got you, I got you. or a companion, I got you. Not a day mate, I got you. Never demanded, I got you. I got you.
For all the dedicated professionals working tirelessly to end cancer, and the courageous souls who inspire them to never give up, no matter the species.
Got you.